I was flying back to State College a couple weeks ago on the backside of a storm, and the plane hit some of the worst turbulence that I ever flew through. But we were warned ahead of time, and I always keep my seatbelt on anyway, so it was just unnerving, not dangerous. But that wasn't the case last Monday, when a United Airlines flight from Denver to Billings, Montana, hit severe turbulence at 34,000 feet over Wyoming. Unbelted passengers and cabin crew were not prepared as the Boeing 737 tilted to the right and dropped violently for several seconds, seriously injuring 5 people. There were no thunderstorms in the area. Some of the white you see on this visible image is cloudiness, but the bright white is snow cover in the mountains. The flight passed near the Bighorn Range of Wyoming and to the east of mountains near Yellowstone Park, and that topography is the likely culprit for the severe turbulence. The mountains creating unseen waves in the air, and there's strong evidence for this from theory, observations, and modeling. Now, when strong winds approach a mountain range and the atmosphere is stable, meaning that air tends to return towards its original level when forced up or down, it's normal for waves to form in the flow downwind of the mountains. If the air is moist enough, the upward moving branches of these waves often form rows of clouds. We even see these so-called mountain wave clouds develop occasionally on the east side of the Appalachians, sometimes even well downwind of the mountains. But in extreme circumstances, these waves can amplify, distort, and even break, producing severe turbulence that's usually very localized and short-lived. So a few thousand feet in altitude, a few miles in distance, or 30 minutes in time can make the difference between extreme bumpiness and a smooth ride. If the air's dry, clouds won't form in the upward branches of these waves, so the turbulence essentially occurs in clear air. And that's what happened last week in Wyoming. But the vertical motions can often be detected by water vapor imagery. In this image from last Monday, the red box marks the severe turbulence. The dark purple indicates relatively dry sinking air, while lighter colors in between indicate relatively moist rising air. Those dark striations just to the east of the turbulence report are the fingerprint of the waves induced by the mountains. And our high-resolution computer models can pick this up too. Here's a forecast of the maximum speed of upward moving air made 3 hours before the incident. The light blue bands over north-central Wyoming indicate corridors of fast upward motion, and a similar pattern appeared in forecasts made 7 hours before the incident. The bottom line is that our models are good enough to at least identify general areas where turbulence could be a big problem. In the U.S., the eastern side of the Rockies is infamous for these mountain waves, but the combination of satellite imagery, modeling, and reports from nearby aircraft make what happened on that United flight last week rare in modern aviation. Fred is back next with the extended forecast.